Hi, welcome to my video on the second derivative, d squared y dx squared, and this is number 2 video. Find the second derivative, d squared y dx squared. So what I want to do now is take you through each step without leaving anything out, just to make sure you understand. So let's do ddx. ddx on each side of the equation, the derivative in terms of x. So the ddx on a subtraction, the ddx is done with each part. ddx of x squared subtract ddx of y squared. Again, I'm showing you all steps. So the ddx of x squared is 2x. The ddx of y squared is negative 2y dy dx. So the derivative, and just to make sure you see that, d dx on the y squared is dy dx d dy on the y squared, so you can see d dy dx. So dy of y squared is 2y. So that's right here. And now we have d dx, the derivative in terms of x on a constant, is 0. So negative 2y dy dx equals negative 2x. So dy dx equals negative 2x divided by negative 2y. So dy dx is equal to x over y. Now let's do d dx again on each side. And I said I'm going to show you every step. So that gives us d squared y dx squared. So the derivative of x over y is the quotient rule. So it's the derivative of x, which is 1 times y, minus x times the derivative of y, which is dy dx. Derivative of y is 1, but you have a dy dx all over, and because we have a denominator or quotient, so it's the denominator being squared. So that becomes y minus x dy dx over y squared. In the next couple of videos coming up, I'll show you what we take the dy dx, and because dy dx is equal to x over y, we'll change this to x over y and simplify it with x's and y's, but not right now, just doing a double derivative. Okay, and another problem to do, if I can get it straightened out here. Okay, here we go. Find the double derivative on x squared plus 2x cubed plus y to the fourth. And again, without going through all the steps, we'll just take the shortcuts. d dx on x squared is 2x, and d dx on 2y cubed is 2 times 3 is 6, and the 3 is decreased by 1 to 2, and it's dy dx. And y to the fourth is 4, and y is the 4 is decreased by 1 to become a 3, power rule. And again, we have dy dx. So anytime you do the d dx on a y, you'll always get a dy dx. So that becomes 6y squared dy dx minus 4y cubed dy dx is equal to negative 2x. And we'll factor out the dy dx. And that gives us 6 y squared minus 4y cubed. And now that we have it factored, so dy dx becomes negative 2x all over 6y squared minus 4y cubed. And I could factor that. 2 is common, so negative 2x. 2 comes out as a factor, so 2 divided into 6y squared is 3y squared, and 4 divided by 2 is negative 2y cubed. So that becomes, the 2's cancel, so I get a negative x all over 3y squared minus 2y cubed. Okay, now we could put the cube first if we want, keep the descending order on the x's and y's, so I can go negative 2y cubed plus 3y squared, descending order in terms of the y. And that we can take out a negative out of that if we want, so we can take a negative out and we get we need to take the negative out at the beginning, but again, when you do, we'll keep going. So it's a negative outside of 2y cubed minus 3y squared, and that becomes x all over 2y cubed minus 3y squared. Now let's do d dx on this. So d dx gives you d squared y dx squared, and we do d dx on this expression. So we do the derivative of f, which is 1, times g, which is 2y cubed 3y squared, minus x, and the derivative of 2y cubed is 6y squared minus 6. See what I almost forgot? When I did derivative, I forgot to do dy dx, and that's not supposed to be there. But I'm going to use my whitener because I don't want it to be hanging around. Just a little error on my part. But I caught my error, which is the main thing. Now, pretend it's not there. Here we go. So the derivative of 2y cubed is 6y squared dy dx minus 3 times 2 is 6y, and we got a dy dx. And that's all over the denominator, which is 2y cubed minus 3y squared, all squared. And we simplify that, so we multiply 1 by this expression to give us 2y cubed minus 3y squared, and we multiply negative x by this binomial on the inside. It gives us negative 6xy squared dy dx. And negative x by negative 6y is a positive 6xy dy dx all over 2y cubed minus 3y squared, all squared. And again, as I repeat, this is the second derivative. If I want to change this to all x's and y's, then dy dx is this expression here. So I would replace this with x over 2y cubed minus 3y squared, and I'll replace dy dx here with the same expression and then simplify it. But I'm not worried about that right now. We'll come in the next video. That brings us to the end of this video. And again, if you like my video, click on the like button, click on the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content of our YouTube channel called Math Fully Explained, which is one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.